Today, we're going to talk about prospecting for oil and natural gas. And prospecting really means let's talk about how do we find it? How do we find oil and natural gas? And we'll talk a little bit about how that's changed over time. What are we looking for and where oil and gas will be found on planet Earth? So, when we're thinking about developing oil and natural gas resources, there's a whole chain of events that needs to happen in order for you to start producing that oil and natural gas out of a reservoir. And so that starts in the exploration and permitting and leasing. That's what we're going to talk about today. And then moves on to like drilling, completing, producing, things like that to actually get the oil and gas out of the ground and then use in our cars and our homes and provide the energy services that they provide. So in honor of this, I've got my drilling earrings on. This is an oil derrick. You probably recognize it. That's how we do the drilling. We do some drilling in the exploration and permitting side as well as when we start doing the drilling for actually producing the oil. So we'll talk a little bit about that today. Key things to know about our oil and gas reservoirs. So when we're talking about oil and gas reservoir, that is just the place where the oil and gas exists under the ground. There's two key aspects that we think about for those reservoirs: porosity and permeability. Porosity has to do with how much volume space is there in the rock that can actually contain the oil and gas. So those are the pore spaces. We typically are looking for porosity of 10 to 30%. Just to give you a visual of that, concrete has a porosity around 15, 20%. So you're thinking about very, very small pore sizes, but that is where the oil and gas is in the rock. That's the porosity. That's what we're trying to gather the oil and rock from, is those little tiny pores. Permeability has to do with how easily things will flow through that rock. So permeability is, are there channels connecting the pores? Are there ways for that oil and gas to flow through? If you think about it, when we want to start producing, right, we want the oil and gas to flow through the rock and then up the well and out to the surface for our production. So permeability is really important so that we can have flow of the oil or gas. When we talk about conventional reservoirs, and we'll talk about what those look like in a minute, we're usually thinking about good porosity and good permeability. Unconventional reservoirs, which are things that we have to do a little bit more to get the oil and gas out of, often has to do with low permeability, or sometimes it has to do with thick oil that just doesn't flow well. So really unconventional has to do with, we have to do a little bit more in order to get that oil and gas out of the ground. So what does it look like? Most of the rocks that we're looking at, think back to when you learned about geology, were sedimentary rocks. Sedimentary rocks are where our oil and gas are formed. It's also where they migrate. So they're often formed by, we talked about this earlier, by squishing biomass into different clays and silt and shales. That's where the kitchen is. That's where the oil and gas is formed. It's going to be formed a lot of times in these shales. Over time, that will migrate. If there's any permeability in that shale, it'll migrate into sandstones, which are also other sedimentary rocks, tend to be higher permeability. And so that oil and gas will migrate kind of out of the shale kitchen into sandstones where there's a little bit more natural permeability and collect in those sandstones. And so a lot of times sandstones are where we're getting our conventional resources. A lot of times our unconventional resources are either from tight sandstones or shales and clays, things we have to do a little bit more to get that oil and gas out. I want to give you the visual that the oil and gas is not in big underground swimming pools. It's not like in a cave with like a lake of oil or something like that. It is actually in these tiny little pores in the rock. So you can kind of get a sense from these pictures. These pictures, they have oil and gas in those tiny pores in the rock. So what does our conventional oil or natural gas field look like? You have your source rock, that's that kitchen, that's that shale where the oil or gas was formed. You typically have a reservoir rock, that's often sandstone, something with a lot more permeability. So over the 100 millions of years since oil and gas was formed, it's migrated into these sandstones and our reservoir rocks. And then usually there's a cap rock. There's something that's keeping it in that sandstone. And that cap rock is impermeable. It doesn't have the permeability. And so the oil and gas kind of gets trapped there, oftentimes with water. There's often water underneath the oil and gas. Oil and gas tends to float on top of this ancient water that's under there. So when you are producing that oil and gas, you're often getting other stuff out with it. Some places you get lots of water, some places you get a little bit of water, but there's other stuff that's being produced with your oil and gas that you then are going to have to separate before you produce and you're able to use that oil and gas from your reservoirs. So that's what a conventional reservoir looks like. And there's a lot of different geology that can happen to form this source rock with a cap, but it gives you the idea that it's in a reservoir that has high permeability and capped by something that's impermeable. Unconventional oil and natural gas, a lot of the unconventional oil and gas that we're targeting here in the United States is in these shales. It's in the kitchen. We're actually getting it out of this low permeable reservoir rocks like our shales where the oil and gas was formed. And so it's oil and gas that didn't migrate into the sandstones. We're actually able to get it now out of the source rock. The other unconventional oil that is also produced a lot is like in Canada or Venezuela, where it's a very heavy oil. And so that heavy oil doesn't flow naturally. And so you have to do a lot to that oil in order to make it flow, in order to produce it. And so that is also considered an unconventional resource. When you're thinking about where can we do our oil and gas, obviously we can't do that development everywhere. And there's a lot of things that limit the places we would go look for oil and gas because of these limitations. So we're looking at the geography of where it was likely formed and how our land masses have moved around. We start with also the places where we could actually develop it. So I'm showing you here a picture of the national parks in the United States. Obviously, those would be off limits to oil and gas development. So there's a lot of land that's off limits. There's water areas that are off limits. There's access challenges to some places that might have oil and gas, but it's really hard to get to. So you think about all of those things and think about where can we economically and regulatorily access that oil and gas. And then there's a lot of different tools that our geologists and our geophysicists use to find our oil and natural gas. So it's not just understanding the geology, where it was likely formed and how our land masses have moved around. We can do a lot of surface mapping. We can do gravity surveys, seismology, things like that. We want to do a lot of mapping of the subsurface, and I'll talk about what that looks like in a minute. And then we're going to map all of that into our computing technology in order to really have a picture of what the underground geology looks like and where we're likely to find that oil and gas. So one of the tools they use is something called reflection seismography. Kind of what it sounds like, you're using sound waves. It's kind of like a sonogram, right? We're using sound waves with a thumper truck where those sound waves will bounce differently off of different types of rocks. We're able to capture those sound waves that have bounced back to the surface and today really do some beautiful 3D imaging of what our underground layers look like. We also drill wells that are for looking at how the underground surface looks like. And so those layers. And so what we do is we do something called electronic logs for wells. And what you're really doing is you're just sending equipment down a well that you've drilled, and it can take measurements all the way down. And then with several of those wells over an area, you can really map out what the subsurface looks like. So this has gotten really sophisticated with today's computing technologies. The other thing we do, obviously, is we look at how well other oil wells or gas wells in the area perform. Sometimes this information is proprietary, but there's also sometimes you can purchase this. But if you think about a developer, they're going to look at how well their existing oil wells or natural gas wells perform, and that will go into where they're going to drill in the future. All right, finally, something that's really important to think about in terms of prospecting and what oil and gas we're going to develop is property rights. And it's really interesting to think about property rights because it's divided up into different things. People have land rights, air rights, water rights, mineral rights. These are separate rights to think about. And so a landowner may not have the mineral rights under their land. Those rights in the United States can be separated out. And this has a lot of implications in terms of oil and gas development and how much of it is actually produced. So in the United States, we actually have 4 different types of ownership: private, federal, state, and tribal. And that ownership can be for the land and also separately for the minerals. We have private mineral rights in the United States. We have state-owned tribal mineral rights in the United States. And we're the only country that really does that. Outside the United States, there's only one type of mineral rights ownerships, and it's government owned. And so you can think about how that impacts the amount that's produced, how it's produced, and just kind of like whether there's a federal strategy for production of oil and gas, or is really down to individual owners and operators. And so in the United States, it's really down to individual owners and operators on whether and how much they're developing those mineral rights. So to access those mineral rights, often a developer will have to work with the mineral right owner, which can be a private person, and the surface rights owner, and those can be separate entities. And so the Chevron or the Shell or the Exxon that wants to go and access those mineral rights has to lease the land to be able to access the mineral rights, and has to make a deal with the mineral rights owner, here called the lessor, often paying them a royalty for any oil or gas they find and produce. And so usually that's some percentage of the revenue that comes from oil and gas that's produced. And so you can see that there are often different payments going on from the developer or operator to the land rights owner or the mineral rights owner. So we're going to talk more about how that impacts production in the United States, and really leads to a lot more oil drilling and oil wells in the United States than really anywhere else in the world in order to access some of those mineral rights. So check that out as we talk about natural gas and oil in particular. All right, so that's prospecting. That's how we find oil and gas. If you want to learn more about this topic or any of our energy topics, check out our website, join our newsletter.